Imagine a world where the weather behaves like an unpredictable beast, growing stronger and more dangerous seemingly overnight. This is not science fiction. It's our reality, thanks to climate change fueling storms that can transform from mild disturbances into monstrous hurricanes at breakneck speed. Hurricane Erin, which recently made headlines, is a stark reminder of this escalating threat. But here's the kicker. The phenomenon driving these increasingly volatile storms isn't just natural. It's heavily influenced by human activity. So, what exactly is rapid intensification? Simply put, it refers to a situation where a storm's sustained wind speeds increase by at least 35 miles per hour within a 24-hour period. For Hurricane Erin, this process was even more dramatic. Its maximum sustained winds shot up by approximately 75 miles per hour in just one day, between Friday morning and Saturday. That kind of escalation is alarming on its own, but when you consider how frequently such events are occurring now, it becomes downright concerning. Why are these storms becoming so much more powerful? The answer lies in two critical factors tied directly to climate change: warmer than average sea surface temperatures and increased atmospheric moisture levels. These elements act as fuel for storms, allowing them to draw energy and grow stronger rapidly. According to Climate Central, a nonprofit research organization, Erin's extreme rapid intensification occurred because the storm passed over ocean waters that were exceptionally warm, waters that have become up to 100 times more likely due to human-caused global warming. It's almost as if we've created the perfect conditions for storms to thrive. And this is the part most people miss. It doesn't stop there. As Erin continues its journey near the Bahamas early this week, it will remain over waters with temperatures hovering around the mid-80s Fahrenheit. Warm waters like these provide a steady source of energy, potentially enabling the storm to strengthen further. Additionally, the warming atmosphere caused by climate change holds more moisture, which means storms can carry heavier rainfalls once they reach land. This combination creates a recipe for devastation, with impacts stretching far beyond coastal areas. If you think this sounds bad, wait until you hear the bigger picture. A study published in 2023 in the journal Scientific Reports revealed that tropical cyclones in the Atlantic Ocean were about 29% more likely to undergo rapid intensification between 2001 and 2020 compared to the years between 1971 and 1990. Recent history offers plenty of examples to back this up. Take Hurricane Dorian in 2019. Whose peak winds jumped from 150 miles per hour to 185 miles per hour in just 9 hours, a terrifying surge. Or Hurricane Ian in 2022, which underwent 2 rounds of rapid intensification before slamming into Florida. Last year, Hurricane Milton shattered expectations when its sustained wind speeds skyrocketed by an astounding 90 miles per hour in roughly 25 hours. Other notable cases include Hurricanes Harvey, 2017, Laura, 2020, Ina, 2021, and Idalia, 2023. Yet despite all this data, predicting when and where a storm will undergo rapid intensification remains incredibly challenging. Scientists understand that certain ingredients, warm sea surface temperatures, moist air, and favorable atmospheric conditions, are essential for this process. However, pinpointing exactly how and when these factors align for specific storms requires further research and technological advancements. Until then, communities must prepare for the unexpected. Looking ahead, the National Hurricane Center predicts that Erin will travel between Bermuda and the eastern coast of the United States in the coming days. While the storm isn't forecasted to make a direct landfall, it will still pose significant risks. Large swells, life-threatening surf, and strong rip currents are expected to affect the Bahamas, Bermuda, the U.S. East Coast, and parts of Atlantic Canada. Even without a direct hit, the ripple effects of such a storm can be catastrophic. But here's where things get controversial. While scientists overwhelmingly agree that climate change plays a major role in these intensifying storms, some skeptics question whether other factors might also be at play. Could changes in measurement technology or reporting practices contribute to the perception of increased frequency? Or is it possible that natural variability alone explains these trends? What do you think? We'd love to hear your thoughts in the comments below. In the meantime, one thing is clear. The stakes are higher than ever. With each passing hurricane season, the evidence mounts that our planet is changing in ways that demand urgent attention. Whether we choose to act or continue debating could mean the difference between safety and disaster.